Okay, hi everybody. What do we got? We got 8 out of 10. Okay. So today we continue and finish the math in China unit. And oh wait, let me just look at the chat for a second. It's funny, my chat window just question 4. What was that? Letitia,
It's the
something about
square root of, I'm pulling it up. Hold on one second.
to do a quick review of the
The square root of 119,716. I use the
so
traditional way, not the Chinese way, because I got stuck with it.
what was it? 119,000.
716.
Okay.
I
So the
got to the
step,
answer using a traditional way, but I wanted to see it in a Chinese method.
okay. Well, the square root of 11 is a little bigger than 3. You put a 3 there
Right.
and a 9 here. That's
Mm-hmm.
3 squared. And you subtract and you bring down the 97. Now the weird part. You double the 3, which
Right.
becomes 6, and you say 60 blank times blank is as close as possible to 297. So
Right.
61 times 1 is too small, and 62 times 2 is too small. 64 times, what is it? It must be 64 times 4 because that's 256.
Right.
So you put the 256 here and you put the 4 there.
Oh, you know what I put up there? 64. Never mind. I understand
Okay.
now. I'm good now.
Then you bring down the 16, you double the
Hmm.
34 to get 680 blank times blank, and maybe the answer becomes 686 times 6.
Okay. No, I got, yeah, okay. I put the double digit up there and I don't know why I did the double digit, but okay.
Oh, the 64,
So
yeah,
I
just,
see
just
where my error was. I see where my error was. I put 64 up there instead of 4. So that was my fault. Okay, I see it now.
okay, great.
Okay.
Now,
I'll redo that question on tonight's homework since it's all on one sheet, but I had submitted for day one already.
okay, you can fix that up. Now,
Okay, thank you.
realizing, you're welcome. I talked to some people after class, and I realized one of the issues is that some people are high school teachers and some people are elementary school teachers. So of course the high school teachers, if you say like quadratic equation, they're instantly, oh yeah, of course, I just taught that, a few weeks ago, sort of thing. But if someone's elementary, they may not have seen that in a while. So these lessons sometimes I'm showing the history of math, but then I like bring in something like, oh, look, it's like a quadratic equation. So I realized what I could do to make this flow better is start with like the math we need for today. Not talking history in the beginning, but just like if you go to the like this question, if you go to the Desmos activity, there's some algebra skills that we have to be able to either already know or we have to brush up on it. There's just no, that there's a certain amount of algebra skills that are needed. You just can't do these questions without them. So, oh, Mohammed asked about 4. The reason it was 4 in that last one was that we doubled the 3 to get 6, and we say 60 something times that same something has to be close as possible to the remainder. And if you try 61 times 1, it's just too small. But 64 times 4 is still less than 297, but 65 times 5 would be too big. So now I have a collection here of questions. There's 1, 2. Let's just start with number 1. Without being able to simplify x minus 3 squared, you will not be able to do the go to word problems. It's impossible. So we have to first make sure everybody can simplify x minus 3 squared. So you can log into the Desmos here. I'll put the there you go. But I know it's hard because some people are just they already know the math skills that are needed. So for them, the course is going to be easier because but some people are having to learn the math skills and the history of math. So it's almost like I'm taking two math courses at one time. I have to learn the history, but I also have to refresh my mind on the algebra. Anyway, let everyone work on. Okay, let me take a look at what people, you know what I should do? Let me do the pace. Yeah, I'm keeping everyone on page 1. Let me just look. Yeah, so I'm really glad I'm doing this because we have to get we have to I have to start with the prerequisite skills because otherwise we learn the history of math stuff and um, you get stuck on as they say the algebra. Okay. So of the people here, yes. So let's look now at what this is. First of all, it is very tempting, and you see this in algebra class where people want to just say, oh, I'll just square like a distributive property thing. But that's actually not true. So if you wrote x squared plus 9, that won't be right. It's not x squared and then negative 3 times negative 3. So that's not going to be the right answer. Instead, in general, when you're multiplying things together, let's just say, I'm going to write it down almost like this. When you have a binomial times another one, I'm just writing A, B, C, D just to like call them just anything. The answer is there's 4 pieces to it. There's AC, that's the first thing times the first thing. There's AD, which is the first on the left. We call that the outers, the A and the D. The inners are the B and the C, and the last are the B and the D. So that is how you multiply together things like that. And then if I just do x minus 3 squared, which is the same thing as x minus 3 times x minus 3. We do the first times the first, which is x squared. The one on the left, the outer left, times the outer right, which is minus 3x. The inner left times the inner right, which is minus 3x. And then finally, the minus 3 times the minus 3. So we do get an x squared and a plus 9, but the minus 3x's don't cancel out. And we get x squared minus 6x plus 9. And that is an essential skill that without being able to confidently multiply, expand something like x minus 3 squared, you'd have a lot of trouble doing the word problems because this is just one step within that. Now let's head over to question 2. Now question 2 here, I have to give you access to it. Okay, now we're all on question 2. Question 2, you'll notice, has the x minus 3 squared there. That's just one step in the bigger question. So everyone work on this one and continue until you actually solve for x. Okay, let me take a look at how people are doing on that one. Okay, try to get it all the way down to an x value. Okay, and I'll come back over here. So as you can see, the x minus 3 squared, well, that's still just like before, x squared minus 6x plus 9. But then I have the plus 15 and the x squared. So what I like to do is combine the 9 plus the 15. And usually when there's exponents, we have to like do some sort of quadratic formula or something, but not in this case, because if you subtract x squared, if you subtract x squared from both sides, you get minus 6x plus 24 equals 0. And then you isolate the x by adding 6x to both sides, and finally dividing both sides by 6. And that's why you get x equals 4. Okay, so, and this is a good exercise just for me to like watch how people are doing. Let's look at, here's just another question that's similar. I think after this one, I'm going to skip ahead. But here's question number 3. X squared plus 56. Now it's not x minus 3 squared. Now it's x plus 4 squared. So that's going to we can't just use the answer that we had from before, the x plus minus 3 squared. So let's do this question, then we're going to jump ahead.
Um, hey, sorry. So I'm doing this like in a notebook. Um, so because I don't really understand every time I push enter for the first line, it like submits it. So I don't know how to keep going on the computer and I'm
Oh,
more
I
of
see.
a paper person. So
Yes, just put it
I
in the final answer if you want. You don't have to show all the work, for instance. You could
okay,
just like
so
do it in your notes and then just put
okay.
a single number as your answer.
Okay, because for question two, like I just finished doing it on my own because you're faster than I am because I haven't done this in a really long time. Um, so then you like moved already to three, so like I couldn't put my okay, thank you.
Okay, yeah, I just opened it up
All right,
back
yeah,
feet.
I just don't want you to think I'm like not following along. I am. I'm just really trying to be able to do it on my own too.
Okay, yes, okay. So I
Okay,
opened it
okay,
up
thank you.
again. Welcome.
Can you go back a slide, please?
Yes.
The cheating. I got stuck at the same spot as I did in the last one.
So in this one, we're lucky that the x squareds, often on questions like this, the x squareds would not cancel out, but luckily in this one they do. So it ends up turning into a question that has no x, it ends up becoming something like this. Whoops.
Yeah, you can, that's all I need to see. You could go back. Thank you.
Okay. So the main difference in this one is, can you properly expand the x plus 4 squared? I like to write it out twice, maybe. I don't know if people still call this FOIL, but that's what I always called it when I learned it as a student. It goes like that. F stands for first with first, x and x squared. O stands for the outers, which is the x on the left and the 4 on the right. I stands for the inners. And L, 4 times 4 is 16, stands for the last, which combines to be x squared. Now you can cancel out, you can literally just cross out the x squares and subtract 16 from both sides and divide both sides by 5. By 8, I mean. And that's how you get your answer of 5. So, you want to look, where did I go wrong if I went wrong? Now I want to fast forward a bit. Oh, actually, I don't have to fast forward that much. Let me just go to this question. Okay, so this is 2 questions up. Let me just go to, this is question number 5, I believe. Yeah. So here is a right triangle. And just as a refresher, the Pythagorean theorem. Anytime someone says the words Pythagorean theorem, they're talking about the fact that in a triangle, right triangle, the 3 sides are related by the relationship a squared plus b squared equals c squared. Yesterday we proved it a couple of ways, but after we proved it, the idea was now that we've established it, we can use it to answer questions where we have triangles and there's some numbers thrown in there also. Like in this case, B and C, it doesn't matter which, as long you have to call C the hypotenuse. A and B could be either, the legs could be A or B. So if I call X A, and if I call A, or if I change the A to an X and the B to an 8, I'll get the right answer. If I change the B to an X and the A to an 8, I'll get the right answer. But I have to call C 11. C has to be 11. That's the hypotenuse. Now, this is not going to be an exact answer. In other words, it's going to be irrational. If you want to make a square root, you can type SQ. I think you type SQRT, and it will make the square root symbol. Oh, I don't even think you need to do that though. Let me just take a look at something. Here's the so over here, yeah. What if I click there? What happens? Oh yeah, I get a little. I get the ability to make symbols. That's good. You could also type just the 4 letters SQRT. But I'll give you a minute to answer this question. Now you could type into the box, confused or not sure. I know it's a math type. It doesn't let you like make spaces and things like that. But you can still communicate through that box. Oh, I see. Some people did number 4. That's fine. You could do 4, but it's but 5 is the question. Actually, do 4 and 5 because I see some people. There's a lot of different answers for number 4. Actually, I see. So everyone do number 4 and number 5. This is number 4. This is number 5. Okay, good. Looks like we're on the same page now. So for number 4, it's 4 squared plus 7 squared equals x squared. 16 plus 49 equals x squared. 65 equals x squared. And 65 is not a perfect square. So we could just write square root of 65. It's a little bigger than 8. But for number 5, it's a little different because this time the unknown is actually a squared. It's like this. So I like to expand it out. And now it's a 2-step algebra question. Subtract 64 from both sides. It becomes 57. And then x is square root of 57. Some people rounded it, they put it into a calculator, but it's okay. You could leave it as square root of 57. So what do we do with this? This is our hold on. Here we go. Now look at this funny question. This is question number 6. And what's different about it is that in this one, see, normally we know 2 of the 3 sides, and we're asked to find the 3rd side. That's your typical Pythagorean theorem scenario. But in this one, we only know 1 side. So it seems like that's not enough information. And you're right. If all I had was 3 and an x, and that 3rd side I also didn't know anything about, like I called it y, that would be impossible. If the question looked like this, 3xy, there would be no way to solve it. But that's not what it says, because even though I don't know 2 out of the 3 sides, I can still do the question. So I want you to go ahead and set this one up, A, B, C. And just watch what happens when you replace A with 3, B with x minus 5, and C with x. Okay, so I'm looking over the answers. Again, this you could run it through the calculator if you want. Oh, or maybe you don't need to. Oh no, you don't need to. You could have a decimal answer. Okay, so I'm looking. Some people haven't. 1, 2, 3, 4, 5, 6, 7. 7 answers. I should have 10. Okay, so 3 more people. If you're not going to type an answer, you could say, you could just type the word confused, just so I know that
I'm still working mine.
okay. Okay, and I'm going to come over here. There's our setup. Now you'll notice that this looks a lot like question number 2. Now here's sort of the danger area. You know, there are some people that like to memorize that in general, when you square something like x plus a, you always get x squared plus 2a plus a squared. And if you square something like x minus a, not the a from a squared plus b squared, but just another letter. Some people memorize that. And that way, when they see x minus 5 squared, they just double the minus 5 to get minus 10, and they square the minus 5 to get 25. Anyway, we get 34 minus 10x equals 0. 10x equals 34. And x equals 34 over 10, which is 3.4. Okay, so that's the prerequisites. I'm tempted to put onto homework assignments like the night before, you know, here's some math questions you want to review to be ready for tomorrow's lesson, that sort of thing. But I'm not sure if I have time to create those, but I hope we're going to skip this question over here for now. And now we're going to look at, this was a question from yesterday now. Now, in the 9 chapters of the mathematical arts, they have in chapter 9, it's a collection of 24 questions that all utilize at some point the a squared plus b squared equals c squared. So there are 24 questions. I am going to go over 5 of the 24, and on the final, and on the homework we have to do for those 5 questions, but with different numbers. You see here, the homework's only 6 questions. There's 5 that are based on questions 13, 7, 6, 8, and 14. And then there's 1 question that's based on something called the Sea Island. So there's only 6 questions we're going to go over today. But I hope this is the one we did yesterday, problem number 13. And I actually have, let me stop that and send you over to question number, oh, sorry. Before we do that, I have a question for you to do, sort of a temperature taking sort of question, which is this. Could you fill this in? It's just like a survey. We are exactly halfway through this course. We've done 7.5 lessons, and there are 15, because the final is not a lesson. So now that we're exactly halfway through, how are you feeling? 1, the math skills. Is that where the issue is? Like, not the history. You understand the setups, but you get stuck on the algebra, the high school algebra that you may have not seen for a while. But then a separate question: what about the history of math part? You know, like I'll show an algorithm for square root or something. That's not really using math that you already know or that you could already know, but that's new for everybody, actually. This history of math part, that's brand new. Even someone who's really good, someone might say that number 1 is way too easy because they know algebra so well, but number 2 they might find hard. Someone else might find number 1 way too hard because they are teaching elementary or whatever, and they might find number 2 easy because they like the logic of it. It's just when they have to do the calculations, they run into trouble. And then there's been 6 homework assignments. Not that many people were turning in the assignments, like 1 each day. Only half the people had the first 4 homeworks done by class on Monday. I didn't say that it had to be in by class. And then another 3 people had the homework in by midnight. and 2 people were late on that, which, so I'm curious, is the homework really hard? And then you could type into this box here. Is there anything else? You could just type in. This one's not math type. You just type some stuff. This is not being shared with anyone but me, but I'm interested to see that. All right. We're looking over. People really wrote nice stuff here, really thoughtful and helpful, and very good to see what people are thinking and where they're struggling and all that. This is very good. We're not, yeah, take another minute on that. I'll leave that page out for you also. Okay, that's very good to have an understanding of what people are thinking. The final exam, which everyone I talk about a lot because it is worth 40% of the grade. Traditionally, most people. So if you get like an 80 or higher, you pretty much have an A in the course. But if you even got a 60 or higher, you get a B. Now, there's no reason to not get a 60. And just for reference, I mean, even if you got a 40, you wouldn't fail the course, but that wouldn't be good. I mean, a 40, there's no reason to get a 40 because, yes, there are some tricky things. So when you're studying, my advice is to, if some of this stuff is kind of hard, there are a few topics you could say, you know what, I'm gonna not study like in Babylonian. I'm not gonna do the kind where there's like a 9 in front of here because that was just one that just broke my back. This thing. So maybe you just don't study that one, for example. So you don't get 100 on the final. You don't need 100 on the final. So I want you to be strategic and not get yourself overwhelmed, because maybe if you try to learn every single thing, you get overwhelmed. So maybe you don't try to do every possible thing, but you say, you know what, I'm just going to stay within, I'm going to shoot for an 80 on the final instead. And by the way, these numbers might change. I mean, it might be like a 75. I'm going to look at the end just to see what happens. Honestly, only one person ever failed. I've been teaching the course for like 12 years. Someone once got like in the teens, like under 20 on the final. And they also didn't do that good of a job on their homework. But usually most people get an A, And there's a couple of B's thrown in there. There's just no reason. I think if you might need to study more than maybe someone else in the class needs to study to make sure you get a 40 or 60, but it's up to you to kind of know where you are. And it's hard. A summer course, 15 days is it's hard. Now let's look at problem 13. This one we did yesterday. I just want to kind of show you it again. So here's the picture. The bamboo was cut and it was 10. I'll go like that. That's 10. That's the sum of the before it got broken. So what we do is we call the hypotenuse 10 minus x. And then they tell us that the tip of the bamboo is 3-way from the base. So you can see now how similar this looks to the question we just did. A squared plus b squared equals c squared. Now that we've reviewed, this is 100 minus 10x is minus 20x plus x squared, not minus, because it's negative x times negative x. That's 9 plus x squared. The x squareds cancel out. The 20 moves over to the left. The 9 moves over to the right. And you divide both sides by 20. If you want, you could say it's 4 and 11/20. Now that is one of the 6 questions that's on the homework. Except I changed the numbers. Like I'm going to come back to this page, but I just wanted to show you. See, question 1 on the homework is based on question 13, but now I made the bamboo bigger. It was 17, and its tip is 13 away. So I changed the question a little bit, and that's what I'll do on the final also. I'll take these 6 questions and just change the numbers, and I won't do any of the other 24 questions. Or, yeah, this is all, I'm teaching 6 questions. And if you understand these 6 questions, you will be ready. All I'll do is just change the numbers to make the homework and also to make the final exam. But are there any questions about number 13, like how I set it up? There's 2 things. Do you understand how I set it up? How I put the x, the 3, and the 10 minus x in the triangle? And if that's one problem you might have had. And then the other problem is, can you solve it? You can use a calculator on the final.
Can you go over how you set it up again, especially the 10 minus x part? How you got that?
Yes. So when you have, before the bamboo gets broken, it was 10. Now imagine I split it up and I told you, hey, I split it here and this is now 4. Well, the other piece would be 6 because they have to add up to 10. If instead I told you that this piece was 3, then this would be 7 because 7 plus 3 is 10. But if I don't really tell you what it is, I call it x, we have to call the other piece 10 minus x. That way they add up to 10. Now I bend this 10 minus x down and it ends up on the ground like this. It becomes the hypotenuse of this triangle. Okay, is that more clear now?
Yes, thank you. I just didn't realize it said that it was 10. I didn't know where the 10
Oh, the full bamboo, yes. Okay, so now we're ready for, we have 5 more questions today. Here is problem number 7. Let's take a look at this. There is a rope hanging from the top of a tree with 3 chi. Chi is like a meter or something, or a foot, like a step, lying on the ground. So we have a tree, and here I have the here's the rope. The rope is hanging like that. Now the rope is bigger than the tree. Then they say that, then they say, whoops. When it is tightly stretched so that its end just touches the ground, it reaches a point 8 sheet from the base of the tree. So what this is this is before. And hold on, let me make a copy of this. And after, what happens is that the rope is no longer on the ground, but it's stretched out. And now they tell us that this is 8. It reaches a point 8 sheet from the base of the tree. Now there's 2 right triangles. You might say, isn't this a right triangle? Yeah, but that's not the right triangle that we're going to use. The right triangle we're going to use is the right triangle formed by the tree, the rope, and the number 8. We need to have the 8. That's one of the pieces of given information. So it's kind of weird because I have 2 pictures. I have a picture that's got a 3 in it, and I have a picture with an 8 in it. Now the question is, how long is the rope? So I'm going to put an X here, since that's the question. How long is the rope? Now the big question for you, and I really want you to think hard about this, what do I need to label the red line, the tree? And let me see if you could type this into, so if you go to question 10 on the Desmos, rather than write the whole answer right now, could you just type in, what should I label the red line segments? What do you think? As a hint, that red line segment is also on the original picture, although it's not like labeled, but that's the same red line segment, so maybe that helps you. Anyway, type in, what do you think about that? Because that's the whole question. Once you have that red line segment properly labeled, it'll be real easy to finish the question, but it's labeling. Okay, so 1, 2, 3, 4, 5. So 6 people have put an answer in. Now, only one person has it right so far, but so don't feel bad. I'm telling you this, not to make anyone feel bad, but just so you know, it's not an easy question. So it's not going to be a numerical answer. It's going to have something with X's are going to be involved. So it's not going to be a number, but it's going to be something with an X in it. Okay, so type in something, even if you type, I have no idea. Just to make sure people are here, will everyone go over to that page? Because I have 2 people who are not on page 10. So at least go over to page 10. Maybe you're thinking about it, so you haven't gone over to page 10, but so I know you're here. Go over to page 10.
Some of us put our answer in the chat.
Oh, okay. Let me see that. I got you. Okay. Now, so don't feel bad if you didn't get this because only two, three actually, 3 of the 10 people got it. So it was hard. Check it out. You see this orange rope here, while it's bent, that itself is X. Is bent. Like this X and this L-shaped X are the same thing. Now the red thing is shorter than the orange thing. And it's shorter by 3 units. So see, the L shape is X altogether. And that's why the answer for the red thing is X minus 3. Basically, it's the rope subtracting away the 3 units of the rope that are lying on the ground. And that's why when you see this question, you set it up this way. There's only 2 numbers. There's a 3 and an 8. The 8 ended up here, and the 3 ended up as the X minus 3, right? Because the tree is short. The tree is shorter than the rope. Otherwise, the rope wouldn't hang, right? If the tree was taller than the rope, there wouldn't be any of the rope lying on the ground. So the tree is shorter than the rope by 3 units. And now we get to see the setup's the hard part, because once it's set up, it turns into one of these questions. That we've been working on. 64. X is 73 over 6. It's 12 and 1/6. So basically there's 2 components. We practice this first. We already practice this type once it's set up. But if you can't, if you don't successfully set it up, then you won't, even if you, so like on the final, I wouldn't ask, here's a diagram. That actually wouldn't be a bad idea, to have some just math questions of the math that we've done and not have word problems. But the final's already long, enough. So on the final, I would ask the question this way. And I would want you to set it up. Maybe I'd even give a diagram, but nothing would get filled into the diagram. I don't know. Anyway, does anyone have any questions either about how to solve it once it's set up, or about why I have an X minus 3 here?
I did something wrong when I was doing it.
Yes?
So I did, the way that I started it was that I did, X minus, like in parentheses, X minus 3 times, X minus 3 plus 8 squared equals X squared.
Yeah, that's good.
Okay, and then I did, like I broke it apart and I did X times X minus 3 minus 3 times X minus 3 plus 64 equals X
You do
squared.
that.
And then I did,
Let-
sorry.
So you did X times X minus. So this is another way to not, instead of using FOIL. Yes, you're allowed to do that. Then what?
Okay, and then I got X squared minus 3X minus 3X plus 64
Oh, but it's
equals,
plus 9 because it's minus 3 times minus 3.
that's where I messed up. Okay.
The 64 is over here, maybe.
No, because then I got X squared plus 9X plus 64 equals X squared.
Why 9? Oh no, it's not 9x. It's minus 6x, right? Because it's minus 3x and then minus 3 more x.
Okay, thank you. That's where I messed up. And that's why I was confused when I saw your answer. Okay, so x squared minus 3x minus 3x plus 9 plus 64 equals x squared. Thank you. I just want to copy it the right way.
By the way, you bring up a good point. If anyone likes that better, instead of doing what I was calling FOIL, if they like the distributive property, you are allowed to do like this. X times x minus 3 minus 3 times x minus 3. You get the same answer. Some people accidentally make that a minus 9 when they do it. So just be careful. Minus 3 times minus 3. And Mohammed asked about the setup. So, this rope, if we imagine, it's kind of weird, but the rope is like hanging down, but it's longer than the tree. So if the amount that's hanging on the ground tells you how much less. See, X is going to be the length of the entire rope. So whatever this is, I'm just going to call it A. This side will be X minus A. That way they add up to X. Because the entire rope, this question isn't asking about how tall the tree is. It's asking how long the rope is. So the rope includes the piece that's hanging off the edge, and then the rest of it. Here's the solution.
How many word problems will we have in the final?
Well, it's not how many word. There'll probably be just 1 or 2 on the final. The more relevant question is how many word problems do I need to study to be ready for those 2 word problems on the final? And the answer is 6. So there's 6 different scenarios I'm going to teach you, and you'll need to know all 6 of them. But on the actual final, there'll only be 2, but you don't know which 2 they'll be. So 2 is the answer to your question, and 6 is the answer to how many do I need to be prepared for? Now you could, I hope that if you're struggling to see like, oh, I'm confused, why is it X minus 3? So 2 things could happen. One, you might say, you know what, this is one of those I'm just going to memorize. When I see this question, I'm going to memorize that X minus 3, even though I'm confused about it. Now, ideally, you try to really fully understand. So maybe you take out a shoelace, and hang it on the ground, or, like if I come over here, if I take a string, let's say the string is already 12 units long, and I hang it on the ground like that, so that 3 is hanging over. Then I say, how big is this? You say, oh, of course, that's got to be 9, because it's 12 minus 3. Well, if I call the entire thing X, I don't know what to subtract 3 from, so I just call it X minus 3. Okay, so that is the second of the 6 questions. We're going to do 4 before the break and 2 after the break. Here is the third of the 6 questions. Now, this one's kind of confusing. It says, given a reed at the center of a pond that's 1 zang. A zang is 10 chi. So on a test, I would not use multiple. I'll just use chi for everything. I won't have conversions. The pond is a square with side 10 chi. Now it says that the reed, which is growing, it's growing from the bottom, from the floor of the, what is it? Is it a lake? What do they say? Pond. So the reed is growing from underwater, and it's growing And it grows so high that it ends up sticking out. But only by a little bit. It's sticking out by 1 chi. So that little amounts to just 1. And they want to know how big is the reed. In other words, they want to know how big is this entire reed. All we know is that it's sticking out by 1, seems. But then they tell us some other interesting piece of information. They tell us that when the reed, is drawn to the bank, it is just within reach. Now that's confusing. What they mean is, if I take the reed and I kind of pull it to the right, if I pull it like a little bit to the right, it would be diagonal now. And it wouldn't be sticking out as much. And if I pull it to the right more, it might only be sticking out a little bit because the reed hasn't changed size. So when I make it diagonal, more of it is underwater. And they tell us that when I bring it all the way to the end, it's now just within reach, meaning it's basically the tip of the reed is on the edge. So this is like a physics thing. You can convince yourself of this. You can take your pencil and kind of tilt it to the right. I wonder if I can do it with my camera. I don't know. I can't see where. Can I see myself? Hold on a second. I don't even see myself. But here's a pencil. So if I'm sticking out above and I tilt it to the right, it's no longer sticking out above, as high. And if I tilt it way, how about this? If I tilt it way to the right, it's totally underwater. So the more upright it is, the higher up that tip gets. And the more I tilt it, the lower the tip gets. So here's what we do. We draw. Oh, they pulled it to the left. I always pull it to the right. And we get a right triangle here. Here's the right triangle. And I call X the hypotenuse because the hypotenuse is the reed. Okay, so the hypotenuse is the biggest side. So the hypotenuse is not x minus 1, but something's x minus 1. Kelsey, it's not the hypotenuse that's x minus 1 because the hypotenuse is the biggest side. But what's x minus 1 is the vertical side. Because the vertical side, see, this entire red line, actually, I'm going to make it a different color because I have too many red lines. This entire green line is x plus is x, which means the 1, if I take that piece 1 off of it, the rest of it is x minus 1. I'll make it a third color. Make it purple. So what our diagram looks like, just make this all in black. Our diagram looks like this. 5 is like it's like the radius of the pond. That was half of 10. X is the lily, the reed, and x minus 1 is the portion of the reed that was underwater. Now, if you want, if it helps you, you could also draw the 1 there. That one's not really part of the that one's not part of the right triangle. But now I want you to complete the question by setting up the a squared plus b squared equals c squared thing. So there's the setup, which again is not, the setup's not like easy, but I think if you practice this setup and we have 6 setups, I hope it's not just like, like gibberish, the idea that the 5 and the X, it's just the X minus 1 is a little confusing. X minus 1, because that's only a portion of the reed. It's the underwater portion of the reed is X minus 1. So underwater, originally underwater portion of reed. If it's sticking out by 1, the original underwater part was X minus 1. Now, when I pull it all the way to the right, it's now fully underwater because it's diagonal. Okay, now this is question 11. Everyone head over to question 11 and complete the question by set up the a squared plus b squared equals c squared, with the x's and the solving for x. So everyone's working now on question 11. Okay, let's take a look. How are people doing here? Okay, that's good. I like what I'm seeing there. I think I'm going to go to another page for it. So it's X, 5. Basically, the width of the ponds, X is this, and I put X minus 1 here because it used to be 1, because originally it was sticking out of the water by 1 unit. Now we say X minus 1 squared plus 5 squared equals X squared. This becomes X squared minus 2X plus 1 plus 25 equals X squared. X squareds cancel out. 2X equals 26 and X is equal to 13, which is the answer to that question. Make sure that's what let me just make sure that's what they asked. They asked, what's the depth of the water? Oh, there was actually 2 questions. What's the depth of the water and the length of the reed? So X minus 1 equals 12 is the depth of the water. And 13 is the length of the reed. Now that I realize they had what's the depth of the water, it makes me also say that there's another way you could have set this up that would have been okay also. You could have called the depth of the water X and the reed X plus 1. and you would have still, it still would have worked. Except you would get x equals 12 as your answer. I don't want to confuse you, so maybe I shouldn't have said that. I should have just stuck with the x minus 1, like told everybody just always call x the length of the yeah, ignore what I just said then and just always call the reed x. Often in word problems, they just ask for one thing. So we call that thing x. But in this one, they asked for two things. They asked for the length of the reed and also the depth of the water. So I thought, well, I could call the depth of the water x, and then the reed would be x plus 1. But oh wait, hold on one second. Okay, I'm back. Yeah, the hypotenuse would still be the reed never broke. It was just more I did reference the questions for homework. Like look, if you look at the homework assignment, it says question 1 is based on number 13, question 2 is based on number 7, question 3 is based. Oh, I'm calling these based on what they're called in the 9 chapters, but I'm just doing them in order. So question 3 is another reed question. Okay, before we do the break, I want to do question the 4th of the 6 types. Okay, take a look at this one. Now, this one is pretty confusing.
What was the second problem? We had the rope on the ground, and then
That was the second. The first was the bamboo, broken bamboo.
oh, okay.
So broken bamboo, rope on the ground, reed pulled to the edge. And now the 4th one. Now this 4th one's kind of confusing. You have a wall, which is 10 chi high. And they have a pole leaning against it so that its end coincides with the top of the wall. So it's something like this. It's a very big pole. And we don't know how long the pole is. So it feels like this looks pretty good. Like it's like, okay, it looks like I have 2 out of 3 sides of a right triangle. And we do, actually. So a wall is 10 feet and the pole is rested against it, so its end coincides with the top of the wall. But now comes something a little bit confusing. If you were to take the edge of this pole and move it to the right 1 unit. You might expect, so I'm sliding it to the right. Well, the pole doesn't change size. So, sorry, can I say, let's just not say it's 1 unit. Let's just say I move it like a tiny bit to the right. In the chat, what would happen? What would happen with the pole if I moved it a tiny bit, the bottom of the pole, a tiny bit to the right? What would happen as far as it's with the wall? What would happen? It would slide down. It would slide down a little bit. It would now look like that. Now here's the weird thing. If I moved it down by if I moved it to the right by 2 inches, you might expect that it would slide down the wall by 2 inches also. Like that would not be an unreasonable assumption. But it wouldn't be, but that's not what ends up happening. It goes down by a different length. So that's kind of weird. Like it's hard to even explain why it doesn't go down by the same amount. But I'm telling you that it does not go down by the same amount. So they tell us very specifically that if I move it to the right by 1 unit, it won't be diagonal anymore, but the pole will be fully on the ground. Let me make the pole red. Even though this top was 10 feet above the ground, when I pull it 1 unit to the right, the pole ends up fully on the ground, which is weird. You might say, well, why doesn't it just go down by 1 unit? You can convince yourself of that, again, by taking a pencil here, off camera, or I'm on camera again. If you take your pencil and you actually say, okay, how much do I need to pull this? You know, if it's like this, let's say, if I pull it to the right a little bit, look what happens. It actually goes down by a lot. Anyway, I promise you that something could get, the bottom could get pulled 1 unit to the right, and the top could go down by 10 units, and that's okay. Now remember that triangle that we had before, the triangle that I wanted to use? That's still the triangle we're going to use. But now I can say something about the bottom side, and it's not X. What is it? You can type it into the chat. What is the, I'll make it another color. What is the purple side there? And Letitia, you are absolutely correct. It is X minus 1. Because the X, now that the pole's on the ground, the X includes the 1. And that's our picture.
How
So
come it's not X plus 1?
why not X plus 1?
Yeah.
Well, that purple line is shorter than the pole, right? Because this red line here. Let me maybe I can highlight it in blue. This is the entire pole lying on the ground,
Uh-huh.
and this here, this point is where the pole used to be touching the ground. So from here to here is X. So from here to here must be less than X. It can't be X plus 1. See, X is not this length from here to there. That's not what X is. X is from here all the way to there. So it's a little bit confusing.
Thank you.
But this side definitely must be shorter than that side because the x is like the hypotenuse of the triangle. And honestly, even if you're having trouble visualizing, I really won't have a problem if on the test, for instance, you say, okay, I just memorized that the amount that I pulled is how much shorter this piece is going to be.
Oh, okay. All right, thank you.
I don't mind if you say, okay, I know there's a 10 there and it's kind of confusing and there's an X here and there's got to be a 1 somewhere. So it goes here, X minus 1 because that one's smaller. Okay, let's have you complete this question. Now that it's set up, go ahead and do the a squared plus b squared equals c squared thing and fill your answer in to number 12, and then we'll take a break.
So the ones we've done so far, the hypotenuse is always X. Is that always the case or no? There's also problems where it's not.
Well, the broken bamboo, the x was not the hypotenuse. It was right in the broken bamboo. The 10 minus x was the hypotenuse.
Oh,
But
that's right.
the other three, you're right. The rope hanging, we made
Mhm.
x. The reed, we made the hypotenuse x. And this one, the pole before it got pulled to the right was x. So yes, the hypotenuse is x in 3 out of 4 of these. Okay, I'm going to look at, so everyone go over to page 12 and you could put your answers in as you get them. Okay. Okay, I see a lot of 50 and a halves, which is 50 and a half is the right answer. Now, if you didn't get 50 and a half, where did it go wrong? Well, one place it might have gone wrong is in the setup. Maybe you called the x minus 1, you called the 10 x squared or different things. But so if you didn't get it right, you need to look and ask yourself, where did it go wrong? Did you expand x minus 1 squared properly? Did you combine the 101? And finally divide both sides by 2. So only you really know which of these steps. Math is funny that way, you know, you can totally see, oh, okay, I made it to this step and this one. You can see like which step, where was your error? You know, if your error was right here, whoops. If your error was, you know, in the expanding, maybe that was the mistake, but only you know. Okay, so that's going to be a good break point. Now, tomorrow, we are in person. North Classroom 3-18. It will be good to see people in person. When they asked me in the course star, they said you can choose. You could either go never meet in person, always meet in person, or sometimes meet in person. And I said, well, since we have to come in for the final anyway, it will be good if that's not like the first time that we ever saw each other was at the final. Maybe some people get confused, what room are we in, that sort of thing. So I had the idea that we'd come in one day a week, except the first week I was out of town. So that's where I came up with Thursday. Okay, there's a gigantic building called NAC. It's kind of confusing because there's like two halves to it, and there's only certain, if you get in on the wrong half, you have to go to like the sixth floor to switch over to the other half. So my advice is to go there early. Like I'm getting there at 9 tomorrow because I have to make sure the room is set up and is there a smart board and what's going on. So I'm going to recommend shooting for 9 a.m. tomorrow for the first time. And then once you know how to get there, it is a pretty confusing building, the way it works with like the two halves that only have like certain ways to navigate from one to the other. Okay, let's take a 10-minute break. When we come back, we have 2 more questions to learn. So I'll see everybody in 10 minutes. And I'm here now if anyone has questions.
Michelle, I think she might have dropped out now that we returned back from the breakout room. I think she disconnected.
Oh,
Oh,
okay.
there she goes.
Okay.
Okay, everybody. Now, this question,
Everybody's not back yet. We left the breakout room because Stephanie lost connection, so we thought she returned. So we came back
oh, I
too.
got you. I understand.
We had
I'm-
finished, but
My
we
computer
wasn't
was plugged
sure.
into an outlet that doesn't work.
Oh, okay, so
There you
you
go.
did disconnect. We was like, are we supposed to go back? So we came back thinking that Stephanie was here, and then I realized it was her computer.
Okay, it's all right. I was gonna bring everyone back now anyway. Okay, I think. Okay, everyone's back. So the big thing here is the multiplying the 7x minus 10 squared. And here's how you do that. So that's so there's two things actually. Letitia had asked about how do you do the 3x squared? Well, 3x squared is 3x times 3x. So that 3 turns into a 9. And that's key. If you wrote 3x squared and not 9x squared, it wouldn't work out. So that's key right there. And secondly, did you come up with this right-hand side? Okay, so that's a sort of algebra skill going on here. I got that. I did 7x. First I did 7x times 7x. That's where the 49x squared came from. Then I did 7x times negative 10. That's where the negative 70 came from. Then I did the negative 10 times 7x. That's where the other negative 70x came from. And then negative 10 times negative 10 is positive 100. So this for those people who are, haven't done algebra in a while, this is a skill that you're going to need if this question comes up on the final. So it's something you're going to add to your refreshing my algebra skills, multiplying 7x minus 10 times 7x minus 10. Now, this is a funny question because at this point, it's kind of weird because usually the x squares cancel out, but not this time. But something else cancels out. What happens this time? You can type it into the chat. This is the first time that the x squares didn't just cancel out, but the hundreds cancel out. Something better cancel out because these questions would be really hard if nothing canceled out. I'm going to subtract 9x squared from both sides. I'll do this in steps. And now I have 0 equals 40x squared minus 140x. Now the easiest way to continue is to add 140x to both sides. And divide both sides by x. And we get 140 equals 40x. So you can see there's like a little bit of algebra. We haven't quite had this one before. If those hundreds didn't cancel out, you were going to need the quadratic formula. But we don't need the quadratic formula in this course. We might need it eventually, but not yet. Not today, we don't need it. We have not come across any question in the whole course where the quadratic formula was needed. And it's still not needed. Divide both sides by 40. It reduces to 7 over 2. Now 7 over 2 is not the answer yet. They want to know how far do the people travel. So I have to multiply that x by 3 and get 21 over 2. So person B goes 10.5 units. That's how far they walk. And person A is 7x, which is 7 times 7 over 2, which is 49 over 2, which is 24.5. And those are the two answers to this question. By the way, I am taping now, but I paused after the break and I didn't realize I didn't restart the recording. So my whole explanation of why we have 7x minus 10 in this spot right here. It's not, we don't have that in the video. I might have it in a different video, but I don't have it in that one. Sorry about that. I even made a note to myself that said, I made a note that said restart recording, restart video, but I didn't do it. Anyway, this is a question that you're gonna, you'll practice.
Can we go back?
Yes, which spot did you get stuck on?
B, calculating B, isn't it 3.5 times 6?
Well, back to the diagram now. In the diagram, B's distance is 3x. So we multiply it by 3. Basically, the x it's kind of like time. So you multiply the 3 times the x. It's not just time though, because it also involves like the speed they're going, but you could think of it as time. So look this over, because this question.
But I still don't.
Yeah.
Oh, it's 10.5. I'm sorry.
Oh yeah, 10.5.
Huh?
Yeah, actually, this was my. Where did I? Here it is.
It's 3 times 3.5, right?
Yeah, that's right. 7.5. So you could write as 3.5.
Okay.
Now, the only way this question can be changed, I'm going to literally have the same question, except I'm going to change. All I can do is change these 3 numbers. That's the only thing I can do on this question to make it different. Change the 7, the 3, and the 10. And otherwise, I'm not going to alter this question in any way except for changing the 7, the 3, and the 10. So if you're really confused by the setup, you could add it to your list of things I'm just going to. I know, because I took some advanced math courses that I got lost in. And I remember saying, you know what? I don't know what I'm doing, but I do know that if I put this X here and this 3 here, at least I get the answer right. Sometimes you just got to do that. They
Can
say
you go back to your answer page?
Here's the answer page.
So, okay, never mind. Wait a minute. Why do you have 7x?
Because the other person, the guy who was going south and then turned, that's how far he went.
So you have to do 7x minus 10.
Oh, but we don't have to do 7x minus 10. That's a good question. We don't need to do 7x minus 10 because the 10 is actually part of how he travels. So that's including the 10.
So why are you doing 7x?
Because look over here, 7x is his. It's not that he started at this point, 10, and just went here. He started here along with B. So he went this way and that way. That includes the 10 and the 7x minus 10, which together becomes 7x. So his full distance, if it said that he started over here, he didn't start there. He started, A and B started together. So it's just said, so the 7x is how far he traveled. Now, if they asked how far was he just going diagonally, that would be 7x minus 10, but that's not what they asked. They asked what's the distance covered by the people. So we do full 7x for that last part, not 7x minus 10. They could have asked how far is he going on the hypotenuse diagonally, but it's not what they asked. They asked for his full journey, which included the 10. And that's why we use full 7x, not 7x minus 10 for that last part. That is pretty confusing because I could make up a different question, for instance, where maybe the first guy is actually starting here and the second guy is starting here and they're meeting up. But that's not what this question was. They started together and one guy went this way and the other guy went like that. So the 7x includes his full trip. So don't do -10,
Okay.
just do 7x. But see, that's an excellent question. Now, this question is very hard. The first time I ever did this question, I mentioned it took a couple of hours even, because I kept doing it in way too complicated of a way. But this way will work out really nicely. These numbers, the 100, is always going to cancel out. Now we're going to finish up today with the 6th question. Today, the goal was to study 6 questions. And the homework is 6 questions. 1 of each type, you see? 1, 2, 3, 4. Question 5 is A and B, but their rates are 5 and 3, and he walks 32. So we've already done 5 of the 6 questions. But the last question is not from the 9 chapters of the mathematical arts even. But the 6th question is from a different book, which is called I think it's called the Sea Island Manual. And this question is sometimes thought of as the 10th chapter of the 9 chapters of the mathematical arts. And this chapter was written by Leo Hui. And here's the way this question works. Let me explain the situation. Check out this diagram. That's like a wood carving from like an ancient Chinese textbook. We're not going to use this diagram, is too hard to follow. So let me show you the situation. There is a sea island. And we want to know how tall it is. And we can't get like so close to it because maybe there's someone going to attack us from the sea island. So what we do is on the ground, we also don't know how far away we are from the sea island. But here's what we do know. If I put a 5, they call boo, which is like a foot or something, a stick in the ground. And then if I lie down on the ground, like face down, and I look up, I'm going to see this here. Here's the sea island. I want to go back far enough so that when I look up at the tip of the stick, my line of sight continues until it hits the tip of the sea island. So if I'm over here and I look, I'll see like the stick and I'll see the sea island. They almost like the tip would go, because this is a straight line, what I see is like the tip of the stick and the tip of the sea island. Whereas if I was too close to the stick might look like it's taller than the sea island. Or if I was too far away, from the stick, this would be the situation. If I went too far away and I looked at the tip of the stick, the sea island would be like above it. So it's a little confusing, but that's what they're saying. And they actually measure the distance, and this is not going to be drawn to scale. They say that it's about 127. That's how far away I need to go from the stick so that the sea island is sort of lined up with the tip of the stick. Now, that's not enough to figure out the height of the sea island. We have to move closer to the sea island Specifically, we move 1,000 units closer. And I take the same stick, which is 5, and I do the same thing. So here's the line from the tip of the sea island to the tip of the stick down to the ground. Through the chat, do you think that this line segment right here, let me make it red. Do you think it's bigger or smaller than 127? Just what do you think? Type in. Do you think that stick is bigger or smaller than 127? That, not the stick. The distance I'd have to be away from the bottom. Do you think that's more or less than 127? Just, well, you don't know the exact number. They're going to tell you it. I'm just curious. Do you think it's bigger or smaller? Now a sneaky trick. So I see smaller and I see bigger. A sneaky trick is to imagine moving really close to the sea island. And if it was really close, you would see that it would be a lot smaller. So the answer is it is going to be smaller. You actually don't have to know that because they're going to tell you how big it is. And I'm telling you, by the way I drew it, it looks bigger. It's smaller though. It's 123. They would tell you. They actually tell you these are the 4 pieces of information that you're always given. You're given the size of the stick. You're given the distance between the 2 sticks. And you were given this number. And you were given this number. Those are the 4 things you're always given. Now I'm going to draw in an extra line because it's going to make it easier to do this problem. I like that line. And I'm going to put an X and a Y here. I'm going to make, see this triangle up here, this nice right triangle? I'm going to call that X and Y. Now that X is not technically the height of the sea island because we have to add 5 to it, but it's going to get us pretty close. So let me say height of the sea island is X plus 5, whatever that is. That's what they want to know. What's the height of the sea island? Sometimes they ask the value of Y also. We want to basically get X and Y from this picture. And I'm going to teach you how to do that now. Okay, here's the diagram, nicely drawn. Incidentally, if you ever want to make this picture, all you have to do is make a nice right triangle, pick a point on the hypotenuse, and go like that, and then make 2 lines, and then finally connect the sea island tip to the stick tip and go down. So that's the picture. 127, 5, 5. I think I'm going to put the 1,000 up here because if I put the 1,000 on the bottom, it's a little confusing. Does the 1,000 include, this piece also? So here's the 123. And this is X. And that's Y. Now I'm going to show you how to answer this question. There are a lot of similar triangles in this picture. For instance, actually, I think can I make a copy of this? I want to do this twice. So let me copy and make it. Okay. So first I want you to notice this yellow triangle and this yellow triangle are similar triangles. By similar triangles, I mean they have the same angles. Of course, they both have a right angle. And you can kind of see, without getting real official here, this angle seems to be equal to that angle. Does anyone know what you do with similar triangles usually? When you have similar triangles and variables and stuff, what do you usually do? What type of equation? I need something with an equal sign. And what is it? Something equals something. Hint? Some fraction equals some fraction. What is it? It's going to utilize the x and the y and the 5 and the 123. How so? Okay, let me come over here for a second. Let me say a little bit about similar triangles then. Here's a big triangle and a little triangle side by side. And this length is, this length is 5, and this length is 20, and this length is 2. So let's start with this. How big do you think that missing side is? If these triangles, yeah, they're in proportion. So everyone look at this question for a moment. No fancy math or algebra. If these triangles are actually similar triangles, like there's a small one and a big one, and I see Marielle wrote x equals 8. Marielle, you can unmute y. You're right. X is 8. Why do you think x is 8?
So I started with the base to get from 5 to 20. I know I had to multiply by 4. So
Yeah.
I did the same with the height. 2 times 4 will give me 8.
That's exactly right. So noticing the scale factor is 4. Another way you can do this is you can set up a proportion. You could go like this, 2 over 5. And then in the other fraction, you put the corresponding sides. So the 2's partner in the other triangle is x, and the 5's partner in the other triangle is 20. And then if you what's called cross multiply, this is just to remind you, this is going to get to the same answer, but it might be more useful for us. So if you cross multiply, you multiply these two together and get 5x. And you multiply these two together and you get 40. And you get the same answer. So I'm glad that we got the answer 8 without that process. But I did want to show you that in general, when you have similar triangles, you can set up a proportion. So here I'm just going to make another similar triangles, and I'm just going to go like that. Similar triangles have all 3 angles equal. And I'm just going to make 4 letters, A, B, C, D. And you can say A over B equals C over D by similar triangles. Well, in this picture, I see similar triangles now. So I can say X is the vertical side over Y is the horizontal side is equal to 5 over 123. And then I can cross multiply and get 123x is equal to 5y, which I can't do anything else with. I'm just going to leave that there for right now. Now, I'll come back to this page and I'll post it also. If I come over here, I'm going to use another color and make it blue. See the 5, 127 triangle? That is also a similar triangle, but it's similar to this thing. Anyone want to say what should go in the numerator of the fraction on the left?
X,
That's right. And what should go in the denominator of the fraction on the left?
Y,
Not y though,
or
because
1,000,
we're getting there. But 1,000
Y.
1,000 plus y, because it's the full
Okay.
distance. So I'll write y plus 1,000. And now when I cross multiply, I get 127x equals 5y plus 5,000. Now I only have 2 minutes, but luckily I'm 2 minutes away from being done with this question. If I take these two equations, this one, and write them down on the same page, one of them says 127x equals 5y plus 5,000. The other equation says 123x equals 5y. Anyone know something very sneaky I can do here to solve for x?
Replace the 5y with the 123x.
Yes. And then subtract 123x from both sides. And get 4x equals 5,000. Divide both sides by 4 and get 1,250. What we just figured out was almost the sea island. We figured out this length. So we need to add on an extra 5 to get the sea island, because so I'm going to say h is equal to x plus 5. Now, that's not how the Chinese did this problem. I mean, they set it up, but they didn't use similar triangles. But for us, this is a really nice way to solve this question.
And I asked, why did you replace the 5y? Oh, because 5y equals 123x. Never mind.
Yeah, so now we got a little bit lucky, right? That the 5y that there actually was a 5y here to be replaced. You know, it's almost like, hey, what if these two numbers were different? Well, they never will be. Those two numbers will always match. So you'll always be able to do this. So incidentally, if they ask for what y is, it would be 123. You could plug the y into this equation. 1255 times 5 equals 123x. Sorry.
Can you go back and explain?
Yes. Which part?
So you took the two sets of triangles and you made this equation.
I made
making them
two
equal.
equations. That's I made two equations, and then I kind of like wrote them next to each other. So I took this equation and this equation,
Mhm.
and I literally just wrote them with the second one written above the first one. So it's not that I
Okay.
set them equal to each other. I literally just wrote them down. And notice, I can do substitution. Let's not worry about y for now. You just get, I don't mean WHY. Let's not worry about the letter y. If you can get the height by adding the x to the number 5, the height of the stick, that's fine for tonight. Now you can see we've now covered, see now for question number, see question 6, I have the same diagram, but I have 4 different numbers. Now I have Now I have the numbers 2008, 11.4, and 17. Sorry for the decimal numbers. I forgot why I made those decimal numbers. I had some reason. Okay, I'm going to stop the recording. What we learned today